There is a moon orbiting Jupiter that NASA scientists privately call the best candidate for life in the solar system. Not Mars, not Titan, Europa. And yet, the clearest images we have of its surface are over 25 years old, taken by a spacecraft that was never designed to study it. Images so low in resolution that entire features the size of cities are blurred beyond recognition. For a moon that might harbor an ocean larger than all of Earth's oceans combined, that is a very strange choice. Act 1. The Moon. Nobody talked about. From a distance, Europa looks calm, a smooth, pale sphere of ice floating in the deep, cold shadow of Jupiter. No volcanoes, no storms, just a white surface covered in thin, reddish-brown lines, like something cracked it from the inside and left the scars behind. For decades, scientists treated Europa as a footnote. Then Galileo arrived. In 1995, NASA's Galileo spacecraft began orbiting Jupiter. It made 11 close passes of Europa over 6 years. The magnetic field around Europa was behaving strangely, fluctuating in a way that solid ice does not explain. The only thing that explains a fluctuating magnetic field on a moon with no iron core is a layer of electrically conductive liquid beneath the surface. Salt water. A global ocean of salt water. Underneath the ice. NASA confirmed it, announced it, and then, for the better part of 2 decades, sent nothing back. Act 2. What's beneath the ice? The ice shell on top is between 10 and 30 kilometers thick, but beneath, the ocean begins, and it is deep. Estimates range from 60 to 170 kilometers of liquid water. The deepest point in Earth's oceans is 11 kilometers. Europa's ocean may be 15 times deeper than that. The total volume of water on Europa is thought to be twice the volume of all of Earth's oceans combined. Every lake, every sea, every river, every glacier on our planet doubled. Hidden beneath the ice of a moon 480 million miles from Earth. At the bottom of that ocean, scientists believe there are hydrothermal vents. On Earth, those exact same vents, in complete darkness, under crushing pressure, without sunlight, support entire ecosystems. Creatures that have never needed the sun to survive. The question is not whether Europa's ocean could support life. The question is why we have barely looked. Act 3. The images that do not exist. The best close-up photographs of Europa's surface were taken between 1996 and 1999, 25 years ago. At their highest resolution, Galileo's cameras could distinguish objects about 6 meters across. Europa's surface covers 30 million square kilometers. Galileo mapped less than 1% of the moon in high detail. 99% of Europa has never been photographed up close. NASA has known about the ocean since 1997. It took until 2024, 27 years later, to launch another spacecraft. Europa Clipper, a mission that will not arrive until 2030. A mission that will not land. No lander, no drill, no attempt to reach the ocean. The official answer: budget, radiation, complexity, all true, but not the complete answer. Act 4. The real reason. In 2016, the Hubble Space Telescope detected plumes, water vapor erupting from Europa's south pole, rising 200 kilometers into space. If real, the ocean is not just accessible. It is already escaping into space, and yet NASA has not flown through those plumes. Here is why. And this is the part most people do not expect. NASA is afraid of Europa, not of what it might do to us, of what we might do to it. Planetary protection. Earth bacteria are extraordinary survivors. found alive inside nuclear reactors, in the stratosphere, inside sealed spacecraft components. If a spacecraft carrying even a single Earth microorganism crashed into Europa and reached the ocean, it could contaminate an entire biosphere. We would never know if the life we found there was native or ours. NASA's silence is not about hiding something extraordinary. It is about being terrified of creating something we cannot take back. Act 5. What Europa Clipper will actually find. Europa Clipper launched in October 2024. It arrives in 2030. 9 scientific instruments, cameras 6 times sharper than Galileo, a radar that penetrates the ice shell, spectrometers that detect organic molecules from orbit. If those plumes contain amino acids, if they contain complex carbon chemistry, the scientific community will face the most significant announcement in human history. Not the discovery of microbial life, not fossils, actual chemistry, actual evidence that Europa's ocean is doing something biological. The mission team is already preparing for that possibility, quietly. In conversations between scientists who have spent their careers on this question, there is a tension that was not there 10 years ago. They think they might find something. Europa is 480 million miles from Earth. Its ocean has been liquid for longer than complex life has existed on this planet. If life exists in that ocean, even simple, ancient microbial life, then life is not a rare accident. Then life is something the universe does naturally, wherever the conditions are right. And if life is everywhere, then the question of what we are and whether we are alone has a very different answer than the one most people are prepared for. That is what is beneath the ice of Europa. That is why NASA is careful. That is why we keep watching.